What is the cobalt-2 concentration when 3.00 grams of cobalt-2 chloride is added to 1 liter of 0.8 molar sodium hydroxide? All right, well, what's going to happen is the cobalt-2 is going to react with 4 hydroxides, and it's going to produce the complex ion with 4 hydroxide ligands. So we need to set up the chemical reaction first. That will be first, and then we will do the equilibrium reaction. So before the reaction, and I figured out how many moles we have, 0.0231 for cobalt. For hydroxide, we've got 0.80, and for the complex ion, there's 0 moles. Okay, so those are our initial concentrations, and we're going to assume for mathematical purposes that all of the cobalt-2 gets used up. Now, what goes here? If you said bring down that 4 and multiply, you're correct. That's going to go down by 4 times the 0.0231. And then what goes over here? This is obviously has to go up because we have a 0. What do I put there? Well, the mole ratio of cobalt-2 to my complex ion is 1 to 1. So that's going to go up 0.0231. All right, so now we can do our calculations after the reaction. Again, cobalt-2 is used up. We get 0.708 moles for our hydroxide, and we have 0.0231 moles for our complex ion. Now let's set up the equilibrium. So I'm going to do this whole reaction again. But this time we're going to be at equilibrium. So we'll apply the rules and calculations of equilibrium. If you look up the Kf value, again, for complex ions, it's very high. Our equilibrium constant is 5.0 times 10 to the 9th. So our equilibrium is going to go way to the right. Okay, so initially we're going to say we have 0 cobalt-2. We're going to bring down the 0.708. And then for cobalt, for our complex ion of cobalt, 0.0231, which is what we just brought down these values. Okay, now, again, this is going to be our ice box, so initial change, and then at equilibrium. Cobalt has to go up, and we don't know how much it's going to go up, so we're going to put plus X. That's what we're trying to figure out. We're trying to figure out what is the cobalt-2 concentration. What's this going to go up? Okay, you should have said 4X. And then this is going to go down minus X. So at equilibrium, we've got X molar cobalt-2. And for our hydroxide, it's 0.708 plus 4X. And for our complex ion, it's going to be 0.0231 minus X. So let's move this up now. And we're going to set up our Kf expression. That's going to be the complex ion so the concentration of our complex over cobalt-2 and hydroxide. Anything else? you should have put this 4 right there. And that's going to equal 5.0 times 10 to the 9th. All right, let's substitute in the numbers. So we're going to have 0.0231 minus x over x times 0.708 plus 4x. Okay, so you should see some very messy math here. We're going to neglect x. What is the amount of x that we can neglect? Which x's? All right, so we're going to neglect this x and this x, okay? And you need to state it. We're going to neglect that. And so x, which is cobalt, is going to equal 0.0231 over 0.708, and also on the bottom 5.0 times 10 to the 9th. All right. And I messed up because this needs to be a 4 right here. And so there needs to be a 4 on the 0.708. Hopefully you caught that. And x turns out to be 1.8 times 10 to the minus 11. And that's going to equal the concentration of cobalt 2. So you can see it dropped dramatically. And then 1.8 times 10 to the minus 11th over our concentration of 0.0231, so can we neglect x, times 100, well, that's going to be way, way less than 5%. So we can neglect x, and you need to show that as well.